This video is on prime factorization. Prime factorization of a number is a number written as the product of its prime factors. So we have to remember that a factor is two numbers that are multiplied together to give you a product. So one of the two numbers multiplied together to give you a product. So for prime factorization, we're only concerned with the prime factors of a number. So one way that we learn how to find the prime factors of a number is by using what's called a factor tree. So finding the prime factors, we use a factor tree. So here's an example of a factor tree for the number 36. So to use a factor tree, you start with the number you're looking for the prime numbers for, and it goes at the top of the tree. So the first thing you want to do is your first branch is going to be a set of numbers that multiplied together gives you 36. So I know that 6 times 6 is 36. So I branched off of my tree 6 times 6. Well, 6 also has some factors, 2 times 3, because 6 is not a prime number. Our tree stops when we get to prime numbers. 6 is 2 times 3. Now 2 is a prime number and 3 is a prime number, so we can stop at this branch of the tree. We cannot go any further. Then we come to this branch of the tree. We had a 6. It is not a prime number, so we find the other factors that can multiply together to give us 6, and it's 2 times 3. 2 and 3 are prime numbers. So for the number 36, this is as far as our tree can go. And we're left with 2, 3, 2, and 3. So the prime factors of 36 are, and I just wrote them in order, showing the 2's first and then the 3's. 2 times 2 times 3 times 3. Or this can be written as 2 squared times 3 squared. So going back to that definition of a prime factorization, it says that it is the prime factorization of a number is a number written as the product of its prime factors. So if we go back to 36 and we see 2 times 2 times 3 times 3, well, 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. Now in this example I use 6 times 6. And I'm going to show you another example using 36 to show you that regardless of the combination of numbers that you use, you're going to get the same prime factors, 2 squared times 3 squared. So another combination of numbers that we can do to get 36 is 3 times 12. So now if you look at my branch, I say 36 is 3 times 12. Well, 3 is a prime number, so I stop. 12 is 2 times 6. That's one combination of doing 12. And I'm left with 2. I have to stop here. But 6 is 2 times 3. So now, using this combination of numbers for 36, I still have 2 times 2 times 3 times 3, or 2 squared times 3 squared. Alright, use a factor tree to find the prime factors of 8. Okay, so at this time, I would suggest stopping the video and trying to use a factor tree to find the prime factors of 8. So our first branch is going to be 2 times 4, because 2 times 4 is equal to 8. Now 2 is a prime number, so I need to stop at this branch. I can't do anything else with this branch. But 4 is a composite number, so I can keep going with 4. And 4 is 2 times 2. And 2 is a prime number, and 2 is a prime number, so my tree stops. So the prime factors of 8 are 2 times 2 times 2, written as 2 times 2 times 2, or 2 cubed. So if we look here, 2 times 2 is 4, and 4 times 2 is 8. So the prime factors of 8 are 2 times 2 times 2, or 2 cubed. Alright, one last example. Use a factor tree to find the prime factors of 48. Again, I would suggest stopping the video, go ahead and do the factor tree, then resume play of the video and check your work. So I'm going to say 48. I can get to 48 by saying 6 times 8. Now 6 and 8 are composite numbers, so my tree can continue to branch. 6 is 2 times 3, and at this point on the tree for 6 I do need to stop because 2 and 3 are prime numbers, so I cannot go any further on this side of the tree. But my 8 is a composite number, so I can keep going. 8 is 2 times 4. Here I can't go any further because I'm at a prime number, but 4 is a composite number, so I can branch off again from 4, and I can say 2 times 2. So now I'm at prime numbers all the way across my tree, so I am finished. So the prime factors of 48, and again I'm just going to write them in order, but I see a 2, a 2, a 2, and a 2, and a 3, so I'm going to write all of my 2's first. So I have 1, 2, 3, 4 2's, so that's 2 times 2 times 2 times 2 times 3, okay? And another way to write this is 2 with an exponent of 4 times 3. And if we say 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 3, we get 48. And that is how you use a factor tree to determine the prime factors of a number.